So kind of skipping the iterator example right now, and moving on to those common collection classes, if you will, right? So we can essentially say, all right, so let's think about particular collection classes and how we would use them. So we briefly discussed ArrayList, linked list, hash set, hash map, and tree map, and I think that these are the kinds of collections that we can very successfully use in different parts of our final project. Okay, so again, to give you a quick perspective, this would be choice number one. If you need to be able to access, if say you somehow need to maintain unique elements, choose a set. If you need to sort elements inside of your container and be able to access elements in your container by keys, you can use a tree map. So again, examples to follow very soon. But these are very popular choices for general, all kind of general programming tasks. So we went through this syntax. Let's see what we say. Do we say anything else that we haven't said already about a collection objects, creation of the collection objects? I would like to make it clear that typically, in many cases, especially if your collection is part of your class, so you have a class named uh, timetable or schedule or some sort. You create object named timetable, and you know that you can populate it with different kind of items, which would correspond to your timetable. But most likely when you create it, and in many cases, it will be empty, right? So in that case, just, in many cases, in those small, short examples, I kind of try to demonstrate it. Look, when you create your collection, in many cases, it'll be empty to begin with. So it's kind of bare bone, creation, and then use it. So, but in overall, this is a very typical syntax to expect, is that collection class. Perhaps let's try it here. Let's try to create a project already started NetBeans so that we can code something and see if it compiles. So again, generics demo main app finish, quickly create just another simple project just to test the syntax as we move along. So here we go, package generics, then class main app, and for example, if I wanted to create an array list, right, I have to specify array list of what. So string is a very easy example. So let's use string as an example, and you have to specify the the type of element to be stored inside the string. And again, this we can call it demo list, something like that. And we have to say new, and we have to kind of repeat this. So it's a little routine and a little boring, but again, realize that this is your data type. And when we say new with objects, we typically specify the name of our class and also use empty parentheses, for instance, if we use default constructor. So goes with this. The syntax is the same. Of course, the NetBeans is unhappy because it has no clue what ArrayList is, unless we say, my favorite hack inside NetBeans is to say, fix my imports. And what I really needed is this. Import Java util ArrayList. So ArrayList is, of course, a class defined in Java API library, and now I have it. So I created my list. It will be a list of strings, but to begin with, I'm expecting that this is empty, empty array list. And in our demo, we just basically say that the collection class name, the element type name needs to be specified. Then you create a name for object reference variable, and you say new, and you also repeat the type, and sometimes you may be using not just empty parentheses, but saying I would like to create an array with like 5 strings already, but that's the that's one of the choices, just to use default constructor, which creates an empty collection. Generic interface requires that the type of object contained in the collection, the element is specified when the collection class is instantiated. So, excuse me. What, excuse me. What I could do here, I could use an interface. Instead of saying ArrayList here, I could reduce my knowledge just simply to the list. And again, I need to fix imports, right? Java util list, this is the one that I want. So instead of just doing everything that I can do with an array list, I could reduce the type of variable which I will use to access array list in memory. I can reduce it to the list interface. Those generic interfaces also have to be parameterized. As you can see, list is just not any kind of list, but a list of strings. So what this little line demonstrates is what we had before on our on this diagram, is that I just created an array list, but instead of remembering that I just created an array list, I remembered a list type of reference. Right? So those are alternatives, and typically you typically don't need to do much more than this interface allows you to do with this particular data type. So this is an example how interface can be used instead of a particular class when you remember what this object is in the object reference variable and use it from that point on. So let's move on. Let's move on to that example. Okay. So again, skipping over the iterator and kind of trying to think about those. Oh, I actually had this example here. So instead of using ArrayList, you can use an interface. And it's very natural, and it's a very wide practice to use when you write code. This is just, as we say, by design. By design, it's very natural to say, I want this collection to use in my code, but guess what? Beyond the point of its creation by new, I would like to stick with this very, well-defined interface, list of strings, and that of course includes everything, pretty much everything that any typical list collection can do. So over here we can populate our list. My list named demo list. Okay, so we can do all this: add, clear, get elements from the list, obtain different other, verify if it's empty, and do all these things because it's a smart object. And as you can see, this list interface is not very small interface. It does a lot. It really does a lot, and it's almost like undistinguishable with what the actual ArrayList object provides. It may provide some specialized methods, but list is not a small interface. It does a lot. So that's why it's very natural to use list of strings as the type of variable that's supposed to remember where your collection is, this demo list. So let's say add, right? So say add and populate it with some strings like hello, right? And then again, I can just copy and paste, hello world, something like that, and so forth, right? So very simple use, very convenient use. And Yeah, you can. Um, let's try this. Let's just say hello world. So I'm expecting that if array like index should be 0, right? Should be 0 right here. Whereas on the next line, when I add another string to my array list, array like index should be 1, right? 1. Okay, so that's my expectation. So that's why then I can say string element, okay, element of my array list equals demo list dot get, and I'm just guessing. If you say get me element number 1 inside of my array list, most likely I should be referring to this string in memory that says world. Okay, so then let's verify it. System.out.print line, okay, and print line element. So we should be printing the word, and then if I say element dot I don't know, just simply assign new string. Something like this. If I assign a new string to it, uh, then if I repeat this again, get it back from the collection, and when I say print it, let me actually make sure I save this.